we're going to finish the session on mathematics of finance, and then I think we will have enough time to also start looking at the other presentation and work that I want us to go through. So that is on data, the collection of data, the presentation of data, description of data. So hopefully we can do that tonight as well, and then next week we can finish off with differentiation. So tonight just doing the final work on mathematics of finance. So we will be looking at annuities and amortization. After that, we can also look at data collection, and then next week we'll go into the differentiation component. Okay, so just a quick recap. So last week we looked at simple interest. We looked at the different formulas for simple interest. So whenever you might be Googling or going to YouTube and look at different videos around simple interest, just remember, as we've done last week, there is different formulas that with different books, different channels, different videos we'll be using. So just always keep that in the back of your head. So we looked at simple interest. We looked at the manipulation of some of the formulas. We've done some examples. In all the examples in this presentation, there is also an answer set. Then we looked at simple discount, where we also looked at the formula of simple discount, and again, depending on what they ask us, if they want the present or the future or the final value, they give us again different formulas for different study guides and books. Then we went into a bit of compound interest, where we looked at interest on interest. So when we looked at the definition again last week, we saw again some things might be different in different examples or different flips. So your amount can also be S, your future value. Your principal can also be your principal or present value. N is normally saying the time period in not years, but sometimes months, quarters, days. So that is where that N comes into. The R is the interest rate, and then T was the number of years. So again, they might be giving us 5 years, but you need to compound it on a monthly basis. So then it would have been N is 12 and your T is 5. Okay, so just again a bit of background in what we did last week. We did one or two examples as well. So this week we starting off with annuities. So, and annuities, you guys can look at, there's a few different types of annuities, but annuities comes down to basically you putting away at a continuous basis money into an investment or into a savings account. Okay, so annuities basically means you putting something away, a, a piece of money for a certain period. Okay, so it might be monthly, it might be quarterly, it might be yearly. So again, different, we'll look at different questions in this to see what we can look at. Then I think the other thing that is important is they, and it's also in your study guide, so they give us the formulas that we can work with. So again, you can decide which one is best for you. So if you want to work with the formula, I will still supply you with a formula page. So when I am back at home, I will scan that formula page and send it to you guys that you have it. So you can use the formula page. You can use your calculators to work out the annuities. You're allowed to use Excel. Um, the one thing that I just want to check again is if you are allowed to use calculators that has been downloaded on your cell phone, because yeah, tonight I'm using one of those. So again, I will just see if I can find out if you guys are allowed to do it. Um, then what is also important is there's basically for you guys two things that you need to nearly remember. So one is your annuity due, and the other one is your ordinary annuity. So ordinary annuity is an annuity that gets paid at the end of a month. So you invest in a retirement annuity, you put in money at the end of a month, interest is calculated at the end of a month. Sometimes it happens that you get what they say it's an annuity due, um, or annuity immediate. And all that means is that when you take out that annuity, you need to pay when you take it out. So not at the end of the month, you basically take it out and you pay at the beginning of a period. But we will look at that because basically, again, where it will be different is um, we will have a different formula, and you will need to do something on your calculator as well. But let's look at one or two examples. So again, you will see, I think later on, I have, no, so not in this presentation, but in the next one. So again, you guys don't need to worry about how this example is. Um, you will always have that your assignments and your exam will be multi-choice. So you will always have that four options of, so it will not be a blank as it is tonight. Um, so let's look at this first question that I want you guys to look at, and let's try to identify a few things. So So they say to us, suppose that at the end of a month, so that basically already identifies to us that we are working with an ordinary annuity. So working with an ordinary annuity, so at the end of a month on his 35th birthday, Ken decides to deposit 400 Rand into his savings account at the end of each month. Savings account pays interest at the rate of 18% compounded monthly. Okay, so that already tells us that it's not going to be a yearly, there's going to be 12 times a year. There is going to be that interest component. What is the amount of money that Ken will have in his account on his 50th birthday? Okay, so what we can also do is just do a simple timeline. Oh, I just quickly want to check if I can get the screen back to a normal size. Okay, cool. So basically 35 up until his 50th birthday. So that means there is 15 years. Okay, so when we use the calculator, there's a few things. So we don't have a present value. So we start off with a 0 present value. We are doing monthly payments of 400 Rand. I'm also going to show you guys how to do it with a formula. So don't worry if you want to use the formula. Then we know the interest rate is 18%. They tell us that the times per year is 12, and it is running for 15 years. So in total, so let's just quickly work out how many periods are there going to be in total. So 12 times 15. So in total, there will be 180 periods. So we've got, and then what do we need to work out? We need to work out what is the amount of money that Ken will have in his account on his 50th birthday. So we want to work out the future value. Okay, so we can firstly, I'm just going to mention the steps on a financial calculator. So I will always start with 0 present value. So 0 present value, then minus 400 PMT. Then we've got 18% interest. We've got 12 times per year. We've got for 15 years. Okay, and then we want to work out what is the future value. Okay, so I hope the thing that I now downloaded can just give me that. Okay, so I probably need to say compute that. Okay, so let's just quickly see if I've done it correctly. I will need to recalculate this on a calculator. But let's quickly see. So R is 400. There's your interest rate. There's your N. You want to work out your future value. So out of these formulas, we would have used that one for our future value. Let me just quickly show you. So there it is. So that's your monthly payment. I plus 1 to the power of n minus 1 over I. So that is the formula that you will use. So okay, and then if you replace everything, you can get the 362,249. I just quickly want to redo this on my calculator to see if I can just understand how the one works that I have downloaded. I will share the presentation as well again on the group, on the WhatsApp group. It will be on Western Cape My UNISA as well, so that you guys can get access to this, so that you can just see how it was done. So let me just quickly go through all of this again. Hopefully I will now be able to do it. So 0 present value, 400 negative PMT, 18% interest, 12 times a year. Then 15 N A, and then if you press future value, you will get that value as well. So it is working out this time around. Okay, so let's look at the next question. So the next one is a bit different, but I think what is also important in this one is one can easily get caught out. So here in the previous question, they showed us 50 years, they showed us the 35, so we could work out. In this one, it's the difference is it's easier always to, well, for me it's easier to see when something is, there's numbers. So the Collins family are planning a trip to Europe and want to have 45,500 in their account in 3 years' time. Okay, so their future value is equal to 45,500. Okay, so that's the future value. Then there is the free. So n is equal to free, so it's not just as simple to pick up the free in number, it is in words. Then they say the account will pay 14% interest per annum. Okay, so that is great. We've got our interest rate of 14. Compounded half yearly. Half yearly is every 6 months or twice a year. So it will be 2 times per year. So let's just put that in here. So if it is 2 times a year for 3 years, then there's going to be basically 6 periods or 6 payments. Okay, so let's just want to take that out of here. Okay, so let's then read further on. What amount must they deposit into their account at the end of every 6 months? Okay, so again, now see we use different words. So after every 6 months basically means 2 times a year. But again, they could have rather said this to us both half yearly or both every 6 months. So they specifically doing this to nearly try to catch you out, so that, because let's be honest, they could have used those words in both. And why didn't they? So just be very careful. They can use biannually to say it is twice a year. They could have it half yearly. They could say twice a year. They could say every 6 months. So there is just a few different ways that they can nearly tell you how to work it out. Okay, so they basically want you to work out the amount that must be deposited every 6 months. So they want you to work out what is that recurring premium or that recurring annuity that you need to pay or that will be paid into the account at every 6 months. Okay, so you starting off with the future value of 45,500. I normally, in my calculator, when I do the financial maths on the financial calculator, what I will normally do is I would put in the zero as a present value just to make its memory nearly clear that it doesn't still use one of your previous sums to nearly work it out. Then 14% interest per year, 2 times per year. So again, 2 PY. Some calculators have P times per year. So some might have X, P, Y. So different calculators have different conventions again. Then for free N, so if you work that out, it would have been 6 periods. And then you can work it out the PMT. Okay, so when you then run that on your financial calculator, you would get 6360.71. I have included also in the presentation again the method. I also just want to show you guys how to do this on Excel, just so that um, you have that view. So let me quickly I just want to copy this over into Excel, and then I just want to show you guys how to do it. So let me do that. Okay, so I think I now need to share again. So let's quickly see. Okay, so hopefully you can see the Excel spreadsheet, so that we can just quickly show how it is, how you can do it. So the nice thing about Excel is that it does have all these built-in functions already. So I'm just gonna put down, let's do present value, let's do sorry, future value, present value. The other one we normally use is the interest rate. Then we have your periods per year or times per year, and then we have N, and we're gonna work out your PMT. Okay, so it was 45,500. It was 0 present value. Interest rate was 14%. Times per year was 2. N was 3. I think that was it. So let me hide the rest of that question below. So let's quickly see which numbers am I missing. So there is, as you can see, there's a PMT function. So the PMT function, let's look at, it's asked for the interest rate. It asks for, but look at what they're saying in the interest rate. So rate is the interest rate per period for the loan. For example, use 6% divided by 4 for quarterly payments. Okay, so we will need to change that, but let's first just look at the other things. NPR is the total number of payments for the loan. Okay, so that means we also need to change something there because it is not just those two. So let's quickly cancel a few things. Let's put in, so that is equal to the 2 times 3. So as we said in the slide back also, we've worked out the periods. And then the other thing that we need to work out is, so that is your interest payment per year. And then we just need to work out what is your interest per period. Okay, so just that we have that. So that is your 14% divided by how many times per year? Okay, so that gives us now the opportunity to let's just add those numbers in again. So interest rate is that, your times per year or numbers periods. Present value was 0. Future value was that one. And then they tell us, is the payment at the end of a period, or is it at the beginning? So it is at the end of a period. And there you see we're also getting the 6360.71. So exactly the same as we got with the financial calculator and with the formula. Okay, so again, showing this so that you just have other options. Um, I know financial calculators to buy a financial calculator is a lot of money, and not everybody has. So I work with a downloaded calculator in any case. So um, again, between that and Excel, I normally get right because one of them will have a function so that I don't need to spend too much on a calculator. Okay, so we get exactly the same as in your Excel um, for that question. Okay, so again, just between the different ways of calculating um, the annuity. Okay, then you guys will also see in your assignments they talk about amortization and what that basically is anything that you nearly pay back over a certain time period and you pay back in a certain periodic method nearly, because I don't want to say it's done monthly because it can be quarterly, yearly, or whatever. But the the best examples nearly of amortization is when you look at a home loan, a car loan, and a personal loan nearly. All of those things you basically pay back on a monthly basis until the loan has been paid off. Okay, so that is nearly um, amortization. Again, there is a formula that we can use with that. We will also be able to use that formula in your assignment. So that formula I have added to the formula sheet, so it is in there. Um, so you can use again the formula sheet. The same again, I want to nearly show you guys how we can use Excel again. So what I will be sharing with you, and I will share the Excel spreadsheet also in our chat, in the WhatsApp chat, so that you have that as well. So if we first look at this question where they say Sibongile purchased a computer for 9,500 and obtains a 3-year loan at 12% interest per annum, compounded biannually. Calculate the 6 monthly payments and draw up a amortization table. Okay, so the first thing in here is let's first work out what that PMT is. And that PMT you can work out exactly the same way that we would have done with an annuity or anything like that. So the only thing that you're going to do is that 9,500, that will be your present value. You pay off the loan, so there will be no future value. And then all the other things, again, also apply. So you will have a 12% interest per year. They say compounded biannually. So now again, just between with different questions. That again could have been twice a year. They could have said twice a year. They could have said every 6 months. So again, just be on the lookout for these things. So, or they could have said 2 times per year. Okay, so, and then calculate. So here they said 6 monthly. That's biannual, and it is for 3 years. So again, one nearly misses that n equal to 3 because it is not a number, but in words. So again, it is for 6 periods. So one could have worked that out to see what will be your monthly payments. So if you work that out um, according to a formula, we would have gotten 19 um, 1931.94. So let me just show again, because that's exactly the same nearly as all the previous formulas that we use. So let me quickly just share Excel again, that we can look a bit on the Excel one. So what I've done, let's quickly do this. Let's just copy it over. Just increase it a bit. So let's just do that. So we know that there is going to be no future value because it's 0. There was a minus 9,500. I think the interest rate ooh, okay, have I now lost connection? Am I back? Just if you can hear me, just do a thumbs up or anything that I can just see that I am back. But please just do a thumbs up. Back. So cool. Thanks. Okay, so yeah, I am I am in a hotel, so it might be if I lose connection again, please just stay on. I will be back. So let's look at Excel again. So we looked at the sum, where we said by borrowing the money, it was 9,500. So future value is 0 because it's a loan, so we pay it off. There's no end value. Present value will be 9,500. The interest rate was 12%. It then also said twice per year or biannually, 3 times a year, so we know that it's 6 periods, and then we will see also that we get that PMT, that every 6 months payment will be 1,951 rand. Okay, so again, we could use your financial calculator. You can use your formula page. You will get exactly the same answers. So again, I will share with you guys the Excel spreadsheet as well. Just for anybody that's not on the WhatsApp group yet, I think you all are, but I just posted the link to our WhatsApp chat in the present or in the chat again. Okay, so that is how to do it on Excel. I will again share both of those, the spreadsheet and the presentation with you guys. So that's on the mathematical side of finance. So the other presentation or piece of work that I want us to also start tonight is your next chapter, chapter 5.